Welcome back. This lecture we're talking about sampling and ethics in research. As we begin our talk about sampling, we need to establish some very important terminology that I'm going to use a lot throughout this lesson, and I've used before, but I'm definitely going to be using throughout this semester. The difference here is between population and sample. A population is everyone who we are potentially interested in. So this could be all VCU students or all psych majors, or maybe it's all humans in general. Now that last one is a huge population that we are trying to understand, but a lot of psychology is trying to understand the human experience. And so we need to think about that entire set of people. But we are never going to be able to do a study where we look at everyone. We can't go out there and get a survey or do an observational study about everyone in the entire world. Or even if we try to do something smaller, like all VCU students or all psych majors, that's still really big of a population for us to analyze. So instead in research, what we do is we take a sample, which is a subset of that actual population. It's the participants we are using in our study that we are then going to infer something about the population. So our sample is the subset, we find out something about that sample, and whatever we find about the sample, we're going to guess that the same is true of the population as it was of the sample. Now, if you are in a situation where you are able to get the entire population for your study, so your sample is the population, you're not missing anybody from the population in your sample, that's what's known as a census. That's when the study involves everyone. And you might have heard the word census to talk about that big thing that's run every 10 years by the US government, where they try to go out and find out information about literally everyone in the United States. Now, it's a little bit of a misnomer because it's never perfect, but it is really, really close because of the effort that the US goes through to make sure that they get data from everyone in the population for that census. But if we are taking a small subset of our population into our sample, and we are going to do our research based on the sample and then inferring something about the population from whatever we find in our sample, then we have a very important question. Do the findings that we got from our sample actually match what's happening in the population? And the way we kind of understand this is, does the sample look like the population? Is the group that I'm taking from the population and whatever psychological effects, their thoughts, feelings, behavior, their demographic makeup, does that represent the population? So I use this term represent because we're talking about representative samples. So the first representative sample is a probability sample. This is when all members of the population have an equal chance, a probable chance of being included in the sample. So who you have in your sample should, by a roll of the dice that they are in your sample from the population, you should get probably the same number of people of different demographic descriptions, or the same people with similar personalities and psychological factors. There's no reason why one demographic or one psychological variable should be overrepresentative. Now, that's not necessarily true that that doesn't happen, but probably with the probability, the sample is going to look like the population. And this has good external validity and generalizability with the understanding that the sample is representative. However, this is very difficult to accomplish, to get a perfectly representative sample. And so we're going to talk about some of the reasons and some of the methods to increase the odds that it is in fact a representative sample, that there's no skew. But if there is some kind of skew, some imbalance or bias, it's what's known as a biased or unrepresentative sample. You'll also see this termed a non-probability sample because it is not probable that everybody doesn't have the same probability of getting into the sample. Some people have a better chance of being included than others. And this gives us a high error in what our population is. So what is this error of estimation that I'm talking about? First, we need to understand that sometimes our sample doesn't match our population. No matter how hard we try, and no matter how representative we want a sample to be, there's going to be some level of error, because this is all just probability. And you can remember from your statistics class that just because something is probable doesn't mean it's going to happen perfectly. So the sample is in some way going to differ from the population, and that is called the sampling error. And so depending on how much sampling error, how much there's that deviation between your sample and population, you're going to have more of a second kind of error called error of estimation. But first, a video. So here I have a video for you. I'm going to ask that you pause the video, this one that you're watching, and go to Canvas and open up this video, How to Read a Political Poll. It'll inform the next few slides. So from that video you just watched, you heard about the margin of error. This is also sometimes known as the error of estimation. This is the degree to which we expect the outcome from the sample deviates from the population data. So whatever we find out about the sample that isn't necessarily representing the population, we think that the population might also be somewhat different in their perspective. There is a sample error, so there is some kind of population estimation error. So usually you get a number of what you think is the estimate along with a plus or minus. So the example it gave for the polls had the plus or minus 4. Or we can have any number of plus minuses. So it could be plus minus 3, in which case that 45% could be as low as 42%, which is just the 45 minus 3, or as high as 48%, which is the 45 plus 3. And we want, ideally, for that margin to be as small as possible. For instance, if we can get it under 1%, that would be fantastic. But this doesn't always happen. And so it is important to kind of understand and find ways to measure how much error you are seeing in your data, how much your inference might be incorrect. And statistics has a way of doing this. It's called a confidence interval, and is a good way of understanding whether or not your finding is what you think it is and is interpreted the way it is. But when it comes to sampling, we're just going to talk about this error of estimation. The error of estimation is a function of 3 things that increase it or decrease it. So if we want that small margin of error, we want to take these into mind so we can really improve our studies. So we are representing the population. Our sample looks like our population and represents whatever we find in our sample represents that population. The first is sample size, we're going to talk about in a second, then the population size and the variance of the data. So sample size, here's a question for you. Let's say I have a population of 100,000 people, so pretty substantial population. I could do a study where I pull a sample of 1,000 people, or I could do a study where I pull a probability sample of 300 people. And looking at these, which one do you think would be a better representation of the population? Which sample is going to be a better representation with less margin of error, less error of estimation? If you looked at this and you thought, hey, I should have more people from the population, you are in fact correct. That sample 1 is a better representation. The reason being that the more we can have our sample equal the number of population, the closer that we are getting to getting everybody from a population, the more likely it is that we are absorbing all of the amount of variance that is happening in that population. If we just took one person from the population as the worst sample, just a single case study from the population, that one person may not represent that population at all. They might be an outlier. So as you increase the number of people, you're going to get a more representative, and theoretically you want to get in statistics, you'd want to get as close to that 100,000. You'd want to get as close to 100% of the population as you can. Now, of course, that's not practical. So what we do is we find a good sample size that is practical, but still high. The larger our sample can be while still maintaining a study's integrity is going to be a better study in terms of sampling and representation. The second part is the population size itself. So the original population, not so much the sample. So when I'm talking about this, it's like envisioning what is the population that I care about. You could have population 1, which is a ideal population that has 10 or 100,000 people in it, that it's representing some big group. So it could be all college students, or maybe I'm talking about a smaller population where it's just 10,000. So that's about a third of VCU students. So I don't know the undergraduate population now, we're still much larger than that, but some smaller population, so a more targeted population. So again, the difference here is how many people we are trying to infer something about, not infer from, but infer about. And so which one of those populations will be better for your estimation? So if you thought about this in terms of the sample size as well, you'll see that the probability sample we have there of 1,000, well, 1,000 is 10% of our population too, 1 out of 10,000, but it's only 1% of our first population, that's 1 out of 100,000. And if what we learned from sample size is that the closer you get to the population size, then you're going to have less error of estimation, that would suggest that population 2, a smaller population size, is better for your error. And that's what I want you to take away from this, that you want a larger sample, but you also want a more targeted population. You want a smaller, more concise, I really care about this population, rather than just talking about everybody. Talking about humanity in general, all 7 billion people on this planet, is going to be really challenging to create some kind of inference and to represent, because there's just too much variation. There's too many different types of people, too many different cultures, too many different locations, too many lived experiences. But if we get smaller and smaller till we're saying, you know what, I only really care about students who are taking Psych 317, well, then you are going to have an easier time and better represent that population. The third one is the variance of the data. So how much are the sample data kind of skewing and showing a range of different behaviors? So here we have a population of 100,000, and our probability of sample 1 is a high variance with 1,000 people, whereas sample 2 is 1,000 people with low variance. So you'll remember from our variance that we're talking again about how much difference is there between individuals. How much do the 1,000 people in each sample differ from each other? So thinking about which one of those, if you have a lot of differences between your population in your first sample versus very low differences between your sample, which one is a better representation of your population? Well, the answer here is a little challenging, because what you're trying to think about is, if I have 1% of the data, how much do I think that there should be variance? And if we're taking a high variance data where that 1% is just all over the place and we can't really target what that one sample's kind of representation is, well, then we're going to have a really hard time of representing the population. But if we pull a sample where everybody in our 1,000 people kind of look the same, kind of are responding to our psychological intervention similarly, or are behaving the same, well, that suggests that, well, if all of them are acting the same, then maybe our population would also act the same. There's not very much difference between these people on this variable, so then our population also wouldn't be. So the more you have a sample that's just kind of, I can't really tell anything about them, the harder it's going to be to get that error of estimation. So what we want from this is a low variance data that we can really tell something about our sample. So that's the second sample is the better one. All right, so back to talking about the two types of samples. Again, we have the representative probability sample, which is a perfectly probabilistic. Everybody has the same chance, and so you're going to have very low error of estimation, versus the biased non-probable sample, which has a high error of estimation. And what we're going to talk about is different ways that we can design our sampling method so that we increase the odds of getting a fully representative sample. Now, it's always going to be a little bit off. We can't know that it is perfectly representative, but we can do things that increase the representation of our sample so that we can better infer information about our population. So here's an image of the many types of sampling that we can do. And we're going to talk about all these green probability samples. So that's going to include a simple random sample. We're going to talk about stratified and systematic and cluster sampling. So let's start off with a simple random. So The major process of representative sampling that we're going to use is through randomization, specifically random sampling. This is where you have a population, and instead of picking and choosing which participants you want to try and build the perfect sample, instead you're just going to take your population and everybody in that population has an equal chance of being selected, theoretically equal chance of being selected. So I have these 12 participants here, but I can't survey all 12 of them, or I can't put all 12 of them in an experiment. So I only have room for 4 people. How do I choose them? How do I make sure that the 4 people I choose represent this population of 12 people? And before I go on, I want to make sure it's clear that this is not related to another term we're going to see later called random assignment. This is when we are assigning to experimental conditions. So we already have our sample and we are kind of putting them in one group or the other. Don't get confused. You'll see both random, but this is random sampling when we're talking about how we're creating our sample, whereas random assignment is how we're assigning to conditions. Okay, but just make sure those are clearly distinct in your head. But we are now talking about random sampling. How do I randomly sample 4 people from this 12-person population? Random sampling, though, isn't so easy as just rolling a dice. In fact, there's 4 different ways we're going to talk about for random sampling: simple random sampling, cluster sampling, stratified random sampling, and systematic sampling. So first, let's do simple random sampling. So the first method of random sampling is the simple random sampling, and this is literally just flipping a coin or rolling some dice or drawing names out of a hat. The idea being that if you know all of the members of the population, then for each individual, you roll dice, flip a coin, draw a name out of the hat, and when you have reached the 4 participants that you want in your sample, well, you're good to go. But this requires what's known as a sampling frame, and that is the initial list of everyone who is in your population. So if I want to survey and create a random sample out of Psych 317 students, well, I have to get a list of all Psych 317 students and then go through each name, roll a dice to see if they get in my sample. But if I have a larger population where maybe I don't have access to the full list of people, how can I include that person if I don't know that that person exists in the population? How can I add them in if I never can roll a dice and I never know that they could be in my sample at all? There's also another issue of the non-randomness of randomness. So here's a joke from Dilbert, a random number generator, and he's sitting there going 99999. And well, that's the problem with randomness, is you can never be sure that it's random. I could roll the dice, flip the coins for my participants, and accidentally get all red participants in my sample. I get 4 red, and that wouldn't be representative. It is simple random, and it just happened that I pulled those names out of a hat, or I flipped a coin for my red participants, and they ended up in my sample, but it is not actually representative. So there is some danger there. And so the next types of random sampling are going to try to get around the fact that you need to know everybody and you don't necessarily have the most randomness from randomness. So the next types of random sampling are just going to take that simple random and make it a little bit more complex. The first is cluster sampling, and this has 3 main steps. The first is that you take that population with a sampling frame, although this sampling frame doesn't need to be quite as comprehensive, but you break that sampling frame into different groups, different clusters of people. You're not necessarily grouping these based on any demographic. You're just kind of grabbing a chunk and a chunk and a chunk and a chunk of the population. You then randomly select that chunk to go into your sample. So in this example of 12 participants, I break them into random chunks of 2, and then I randomly draw 2 of those 2 chunks, so I get 4 participants. I have 2 clusters with 2 in each is 4 participants. And then I use the people who are from those selected clusters. Again, you don't necessarily need to have a perfect sampling frame for this, because you might have random amounts of people in each of your clusters. And so as you are randomly pulling it, some of that variance is going to go away. This also makes it so that you are less likely to get this non-random randomization issue, because inside the clusters, there is a random sample of your population. And so you are adding a second layer of randomness, which as you add more randomness to more randomness creates more randomness, multiplicative randomness, so that you are more likely to get a probabilistic random sample, a probabilistic representative sample. If we want to make this even more complex and maybe even more representative, we use what's called a multi-stage sampling. This uses the same kind of steps of breaking the populations into clusters, but then we also randomly select participants from each cluster. So you're randomly dividing them up. You are then randomly selecting which cluster you're looking at, and then randomly selecting a few participants from that cluster. So now we have 3 levels of randomness. We have first randomly dividing up our population. Then second, we are randomly choosing clusters. And then third, we are randomly choosing people out of those clusters to put into our population. So randomness on randomness on randomness, the more layers of randomness we can add to our sampling technique, the more likely we are to get, or theoretically, the more likely we are to get a representative sample. The fourth type is called a stratified random sampling. This is similar to that cluster sampling, that breaking up into groups, but here we have a little bit more intention. I mentioned with the cluster sampling that they're just kind of randomly assigned to a cluster. There's no idea of making sure one demographic is in a cluster or one type of person is in a different cluster. Here we are breaking it down in demographics. For instance, we might have men in one cluster and women in another. We could do it based on different racial identities or political leans or the age of the populations, and you break them up. So here we have the color of the participants as blue, red, and green as the 3 clusters that we're putting in, and then we randomly gather from each cluster. We also want to make sure when we're doing this stratified random sampling that we are including a proportionate amount of randomly chosen individuals from each cluster. So in this example here, we have 1 out of 4 in the population are blue, right? That's 3 out of 12 is 1 out of 4. You have 1 out of 4 also green, because there's 3 out of 12. And then we have the 6 out of 12, or 1/2 of participants are red. So when we are creating our sample, we want to make sure that we draw 1 person, 1 out of 4 from our blue, 1 person, or 1 out of 4 from our green, and 2 people, which is 2 out of 4, it's half, from the red group. You see how the number of people in our sample is representative of the number of people in the population, but we are randomly choosing the individuals who are going to represent their cluster or their demographic group. So again, we randomly sample from each group to ensure the correct representation within our sample. So here again, you need to have that sampling frame of knowing, what does my population look like? What is the general breakdown of my population, so that I can verify that within my sample, I also have a good representation. Now, the issue with this is that you are going to represent on the salient characteristics, like if I know that it's race or age or political leanings, I know that about my population, well, I can verify that in my sample. But there are a lot of psychological characteristics that we don't just know about a person. So it might be that participant 2 and 8 are from the red group, but their views and their political leanings and their psychological variables don't match the other red participants in any way, or the other red population in any other way. So we're kind of hedging our bets that the way we create these clusters is well-intentioned, and that the people in the clusters are representative of their cluster at all. The final method of random sampling I'm going to talk about is the systematic sampling. And this is where you pick a number of iterations and you take the data for every person who is at that iteration. So here I have the example of every 3rd person. So you could do a study where you're looking at ER patients, and you decide randomly that I'm just going to take every 3rd person who comes into the emergency room. So there's your population of 12 people laid out. And one person comes in, not sampled. One person then comes in and is sampled. Then two more people come in and are not sampled. And then the third person comes in and is sampled. And you go about this. And the idea is here that there's no systematic way that people are approaching you. There's no systematic way that certain people are coming into the emergency room. So every third person should be relatively random. This technique is also used for audio recording methods. For instance, there's the electronically activated recorder, which I talked about in week 1, is just a little smartphone that you wear. It's an app. And instead of recording everything that you do, because that would be a lot of data, every audio interaction, every conversation you're having, all of the hours that you're sitting in front of Netflix just kind of listening to a show in the background, instead of sampling all of that and then the researchers have to go through all of it, instead they just sample every few minutes, a few seconds. So I know there's some settings where it's 10 seconds of recording every 9 minutes or something like that, something weirdly random. And so what this is important to understand is that it doesn't have to be just your participants that you are systematically sampling. It can be really anything. The only rule is that it has to be consistent. There has to be some kind of logic that does not have a systematic method of, or it can't introduce some kind of systematic bias towards collecting certain data. So if you only surveyed every time a red person walked through the ER, that would be a systematic issue, and that would be a problem. But if you have some arbitrary measurement, an arbitrary timing, an arbitrary system, then it is okay. So here are the 4 represented again. You have again that simple random sampling where you're just randomly sampling people and just pulling from the big population. You have your different kinds of cluster sampling where you're just grouping people and then randomly pulling from each group. Then you're stratified where it's not so random clusters. Instead, you're trying to you're dividing people up based on their demographics and pulling in a proportionate amount of people from each of those clusters. And then your systematic sample where you're sampling every nth person. I'm also going to include a video for you to watch that goes over a lot of these systems, provides some more examples of how sampling can be done. So definitely check that out, watch that so that you have an even better representation than I'm giving you of these different types of random sampling. Now we can have all these fancy methods for creating our sample to get as representative of a sample as possible through these random methods and the layering of randomness, but we're still going to have some challenges. First, all of these sampling techniques are going to underrepresent the non-reachable people. So even if we want them in our sample and we think that they're the perfect representation from the cluster and the multi-stage and they're the third person or whatever, if we can't reach them through phone or an address or an internet access, then we can't sample them. A lot of people are not recorded in these sample lists, so we don't even know that they could have been in our sample at all. We don't know that they were from our population at all. And so not being able to reach those or not having a good understanding of our population or a way to access our population can significantly hurt our ability to represent. And so we'll find that these non-reachable people they don't show up nearly as much in our psych studies unless there is an intentional effort to go about reaching these non-reachable people. For instance, studies that are directly for studying people who don't have phone or access to internet or are homeless so that we can actually reach them. We also know that we have different levels of response rate from participants, that some people just don't want to respond once we do reach them. They say, oh, this is really annoying, I'm eating dinner, or I just don't like surveys, and so they shut down and we don't get their information. And so we want to provide a lot of follow-up to get those participants. We want to provide incentives so that they are more likely to want to play ball with researchers at all. But of course, we can't force them to do those. So instead, what we do is the people who didn't respond to us, who have chosen, no, I don't want to participate in your study, we try to collect what information we can about those participants and see if that kind of participant differs from the people who don't. If we can measure something about the non-represented or the non-responding population, that can still inform our margin of error. In fact, that's where that margin of error, that error of estimation comes from, is in all of these polls, people are doing a lot of research to understand all of the people we didn't sample and didn't respond. What do we generally know about them, and what do we generally know about how they might match our sample? Are they, on whatever metrics we do have, similar to our sample or not? And the more dissimilar they are, the more they are not similar, then we're going to increase that margin of error. But if we find that, oh, hey, the people we didn't get response from, they actually look pretty similar to our population anyway, there's pretty low variance in the population as a whole, well, that's pretty great for us. And so we can say that we have a higher level of representation. We also want to be careful about misgeneralization. This is when we do collect a great sample and we say our sample represents our population, but there is something systematically different. For instance, here our population is the parents with school-aged children, but it could be the fact that we collect only students who are from public schools versus only parents of children who are from private schools. And if we do one of those groups and not the others, if we don't have good representation, then we are misgeneralizing. So we always want to see how we want to look at our sample and our population at the same time to see more about, do the things we know generalize between the two? Can we infer something? Okay, so I've talked a lot about the representative sample and how we can go about that, and maybe some problems with representative, why it's not always representative. But I did mention at the beginning that this is very difficult to accomplish, that it takes a lot of effort, knowing the population, having that sampling set, which is something we don't often have. And so the other kind of sample, when we don't have access to that list and we don't have a perfect methodology for getting the most representative sample, is going to be what's called a biased sample, again with that high error of estimation. Here, back to our many types of samples image, we have those non-probability samples down at the bottom of purple. We have our convenience sample, our quota sample, and our purposive. Those are the non-probabilities we're going to talk about today. So when understanding our non-probability sampling, we need to again know that it is impractical in some times to obtain a random sample. In fact, not just sometimes, very often it is impractical. A representative sample is the ideal that we are going for, and that we are theoretically designing everything around wanting our stuff to be representative, but it's just not going to happen a lot of times. So we need to go into these non-probability samplings with an understanding that they do have this bias, but as long as we take it with a grain of salt, as long as we understand what that bias is, we can still use it. These are more common in experimental research whenever we are testing a hypothesis about how something will affect the participants. That's going to really help us. And when we're trying to describe the population, we do need more of a representative. If we're saying this phenomenon happens all the time in the population, and I know that because I sampled something, that's harder to use a non-probability sample. But if we're just trying to find out, does my phenomenon result in what I think it will? Does it have an effect on humans in a way that I think it will? We can generally use a non-probability sampling there. And this is a difference between the fully inference and a light inference. We also know that this generalizability can be assessed via replication. So I talked first week about how we are going to have lots of different researchers through lots of different methodologies trying to do the same kind of experiment, and they're going to be in particular using lots of different samples and looking at different populations who have different backgrounds. So while your sample might not be representative of the whole population, and the other researchers might not be representative of the entire population, each of those studies all pulled together means you have all sorts of people from all sorts of populations and all sorts of samples are all pulled together. And so together, when you look at it comprehensively at all of the research that's been done through all of these different samples, that is representative of the population. That is what gives us generalizability. This is why no single study is really taken at face value for this is what humans are and how they act. We need to have a lot of different replicated studies. So the first kind of non-probability sample is the convenience sample. This is the easiest. It is the most convenient sample. Ha ha ha. So this is sampling from anybody who is just readily available. This is the Greenpeace person standing on the street saying, would you like to fill out my survey? These are when psych researchers are saying, come in through the lab, the open door, whoever wants to come in and sit and do my experiment, come on in. So this is just pulling random people around Richmond or random students or these shoppers at a mall and just going up to them and asking them, can you participate in my survey? Most of psych research uses convenient sampling. We just say, if you want to come to us, we will do research about it. Now, if we want to be a little bit more sophisticated, we can do what's called a quota sample. This is the same as a convenient sample, except we are making sure different proportions or quotas are met. So we want to make sure no single group is overrepresented in our sample. So maybe we're doing a survey about drinking, and based on prior research, we know that more men than women drink alcohol. Maybe we know that 67% of men drink alcohol and 33% of women drink alcohol. Made up numbers here, don't quote me on this, but let's say that's the information we have. So that when we are collecting our convenient sample, we want to make sure that when we want to collect 100 participants, well, when we've got 67 men in our sample, we can just stop there. We've had 67 men walk up to us and say, yeah, I'm interested in your drinking survey. Well, then we say, all right, thanks. And then 68th person comes by and we say, no, thank you. We already have enough men in our sample. And the same thing with women. We have 33 women who want to join our sample who are conveniently joining our sample. And then after that, we say, nope, we've reached our max. We are good to go. We have our 100 participants, and those 100 participants are in some way representative of the population. The last is a purposive sample. This is when you are using the researcher judgment to pick and choose participants. This is the almost exact opposite of a representative random sampling, because random, you're just taking everybody and they have an equal chance. There is only the chance that the researchers described. I want this person in my population. And usually these participants are chosen because they have some very salient characteristic that the researcher needs in their study. They need to analyze these people. For instance, if you're studying an election, maybe you need people who actually voted, and maybe you need people who actually voted a certain way. If you're researching products at Target, you need people who have bought that thing at Target. Especially if you're test marketing a specific product, it doesn't help you to randomly sample from the participants and 99 out of 100 of your participants says, I've never even heard of your product. You want to very specifically target and very purposefully target the different participants. This comes into psych research a lot, especially with physiological, that if you are going to study an individual who has epilepsy, you can't just sample from the entire population. You need to find someone who has experienced some kind of epileptic seizure so that you can understand the brain chemistry behind that. So this method is rarely used because it does introduce a lot of bias in the judgment, that the researcher is trying to choose certain participants and they might have some skew about who they're choosing and who they're excluding from their population. But it can be used in very specific scenarios, and there are plenty of examples of it in research. But it does come with a big grain of salt and an understanding that it's not representative of the population, it's just representative of the kind of people that were chosen for this study. Speaking of people who are chosen for the study, we have a big issue of self-selection. Self-selection is when the individuals in the sample are the ones who volunteer. So that convenient sample, people are walking up and you're saying, oh, please join my study, but most of them are saying no. Well, the people who do volunteer, well, they might look a little bit different. So this is an issue for all researchers, that we can't reach everyone. This is a particular issue for internet polls where the people who decide that they want to respond are usually people who are highly motivated. You'll see this if you go on to student reviews or Yelp reviews, Amazon reviews. The only people who post are the people who have really extreme, they just need to share. So the people who really loved a product, or the people who hated that product, it broke on them, or the people who love a candidate or hate a candidate. You don't get so many really middle ground who just kind of are meh, don't really care about it. They're not motivated to volunteer. They're not motivated to care about the thing being studied. So trying to overcome that self-selection is an issue because these volunteers look different from most, they look different from the entire population. So compared to non-volunteers, the people who decide they don't want to participate, the typical volunteer tends to be higher in socioeconomic status. They have more income, better education generally. They generally showcase higher IQ scores. They're more interested and curious about what the research could be. They also have a higher need for social approval. They're more likely to say yes and to try to be helping out. And oh yeah, you research, I'll totally fill out your form or take this survey because I know that you really want it and really need it. They're also more conscientious. Conscientious is one of the big 5 indicators. It basically shows how much you are a rule follower, how much you care about established systems, the make your bed, turn your homework in on time, the listen to every rule that is told you, all the methodology by the researcher. And we also find that these individuals are more extroverted. They're more outgoing, more interactive, more out and about in the first place, more interested and curious about social participation in the kind of research. So if we know these things, well, our whole population of people might not look like high SES and high IQ and very conscientious and very extroverted. There's going to be plenty of low conscientious, introverted, low SES individuals in the population who are not going to be as representative. So that's when this random sampling comes in, and this is where incentives come in. Now, the last point I want to make is about how many participants you should be collecting that you ideally want to bring into your study. And this requires a consideration of a statistical term called power. Power is just the ability of a research design to detect the effects. So we talked about what an effect size is how much you are actually being able to identify that your IV is affecting the DV. And so the more power you have, the more likely you can find effects. In fact, there's a special equation in statistics that is power equals effect size times sample size. So power is the result of the level of effect, the level that your IV is affecting the DV, multiplied by how many participants you have. And if you have a really strong effect that there is a connection between these two variables, well, then you can have a small sample size because the effect size is so large that you do have enough power to detect that statistical effect. But if you have a small effect where things aren't necessarily, they're sometimes related to each other, there's some connection between your IV and DV, but it only happens in certain situations, or it's a little rare or has a lot of noise, well, then it's going to be really hard to detect because that multiplicative with the sample size is going to be really hard to detect in a small sample. So if you do have something that you theoretically think is a small effect, that there is a relationship between these two variables, but it's just really small and really situational, then you need to have more participants. Larger samples have more power, and therefore they have the ability to detect that small effect. So a lot of times in research, there's what's called a power analysis, which is where you hypothetically imagine what your effect size will be for your study. And based on that hypothetical effect size, usually based on past research, you estimate how many participants do you need in your study in order to actually detect your effect, that you can actually do it. And so you might find that in a high effect size, you only need 10 participants, but in a low effect size, you might need 1,000 participants. And so going back to the first step of talking about the sampling error and how we want to have larger sample size, but we can't practically get everybody, but we want larger. Well, this is a good way of saying, how large do I have to create my study to get my effect without going overboard, spending too much money, too much effort to get there. Okay. So when we are considering our sample size, and I said that you're trying to get these participants, you're trying to get volunteers, and sometimes people don't want to volunteer, but you need them to, and they don't respond, but you need them to. Well, researchers have some level of power to find participants and to motivate participants to take part in their study. But this is a great time then for us to talk about the ethics of recruitment. And so we're going to do our chapter on ethics right now. Any conversation of ethics will usually begin with an understanding of the Belmont Report, which was a 1976 broad set of principles to establish a guide for human subjects research. This was largely motivated by the Tuskegee syphilis study, which in very short form, and everybody should look into this more, is a study where the US government wanted to understand the health effects of syphilis in Black rural men. And the way they did this was by finding a bunch of rural men, Black rural men who had syphilis and who didn't have syphilis, and watching them through the progression of their syphilitic disease. Basically, they let the people die from syphilis, and they tracked what the effects were on the Black male body during this time. At any point in this process, the health department could have given some kind of remedy to these individuals, but because their whole purpose was to understand this health concern, they let a lot of people just suffer and die. And while there was some information learned about this, what it established was that there are certain levels where research for understanding is not okay at the expense of individuals. And it established three principles. First, there's a respect for persons, that the individuals who were signing up for this study thought that they were going to be getting some kind of health remedy. Many of them didn't even know that they had syphilis. They were found through other means. And so particularly for groups who have reduced autonomy, like children and prisoners, it's very important to tell the individual what they are going through, what you are doing, why you are doing it, this informed consent. They are an autonomous individual who needs to be able to make choices for themselves, and we are going to respect the fact that they are an autonomous individual who can make educated and informed decisions about themselves. The second is beneficence. This is where we are protecting all participants from harm and ensuring their well-being. So just because we might get a lot out of a study doesn't mean it should be at the cost to the individual. Now, there are certain situations where the benefit of some study might be so incredibly high that we can introduce some cost, but that is not at the researcher's discretion. There, in fact, are going to be entire institutions set around the amount of harm that is done and the measuring the harm versus the benefit, and that benefit better way outweigh any kind of harm, and the more harm you are going to include, such as letting someone die from syphilis, there's basically no benefit that is high enough to allow for that kind of research to happen anymore. The third is for justice. This is where you have a fair balance of the benefits and costs associated with participation, that the individual who decides they don't want to participate isn't hurt any more than someone who does. Inclusion and exclusion shouldn't affect an individual's life outcome. All right, so with these three principles in mind for the Belmont Report, we have developed a lot of systems in place for ensuring that these principles are met. In fact, the APA has set up ethical principles and standards. The APA is the American Psychological Association. Those are the same people who are telling you how to cite all of your journal articles. And they have a number of enforceable standards. The key issues that they are addressing are that you need to have institutional review boards, IRBs for short. There are rules about coercion and undue influence, rules about how we create informed consent to reach that respect for persons. Also deception, how much are we able to lie to participants about what we are doing in our studies. Debriefing, which is when we make sure that the participant is okay after our study. And then what happens if people do something that they shouldn't have done during the research, there's any kind of misconduct. And then finally, they've established rules for animal research and how we can make sure that not only are we respecting persons, but we're also respecting animals in our research process. So the first kind of key principle that is reviewed by the APA is the establishment of institutional review boards. These are committees that every research institution has that reviews the research that's being conducted to make sure that it meets those three principles of respect for persons, beneficence, and justice. And all of these reviews need to happen before the research is conducted. So anytime you want to do some kind of research study where you're collecting participants, you have to submit to an IRB to say, this is what my research is, and I want to collect participants. This is the amount of harm I'm going to do. This is the benefit I'm going to get from doing this study. And this is why I think that the benefit outweighs the harm. Here's all the steps I'm going to take to make sure that participants are okay after my study, that I'm not causing any long-term effects. Here's all the ways I'm going to reduce harm as much as possible. There are a lot of questions that need to be submitted, a full mock-up of the research so that the IRB reviewers can know exactly what you're going to do to participants to make sure that nothing you are doing might have a negative effect, might break one of those three guidelines, those three principles. And the IRB is always looking to balance the welfare of the participants with the researcher's goal and that contribution, that cost-benefit analysis. And IRBs are very strict, and they have a lot of editing processes to make sure that you have the most boiled down, least harm version of your study, so that you can respect persons, have that beneficence and the justice. There are also rules about coercion and undue influence. This is particularly important when it comes to our sampling conversation, how we are bringing people in, how we are incentivizing. So coercion is any kind of explicit or implicit. So that means you are saying, explicit is you have to do my study. Implicit is just a suggestion of, if you don't do my study, something bad might happen. So any explicit or implicit suggestion that someone who chooses not to participate might suffer, that is coercive. There's also undue influence, which is when you offer an incentive that the person can't say no to. Hey, take my Tuskegee syphilis study where I'm going to let you die from syphilis, but I'm going to give your families $1 billion because you suffered through this. That is undue influence. We have to be really careful about framing what the incentive is, because it's one thing to give a few dollars to someone for participating, but some people really need that few dollars. Some people might think, whatever, I could take it or leave it. It's not that big of an incentive. But some people might really need that incentive. It might be very attractive. And so tailoring the attractiveness of our incentive to get our different samples is a big part of the IRB. So again, making sure you're not giving too much of that incentive and reducing it. So whenever you're submitting to the IRB, you do have to include what are your incentives and what is your intended population, and how might that incentive be attractive to your population. Speaking of how we share the information about incentives, there's the informed consent, which is in every study the information about the study so that participants can decide, do they actually want to get involved? So even if they see, oh, I get $100 for doing this study, well, what is this study? What are you going to do to me? Is this something that I want to experience? So it has a brief description of the procedures, of what the person is going to experience. It lists out all those potential risks to the individual and benefits. This is not benefits necessarily to all of research, like why are we going to get great research from you, but what are the benefits to you? What are you going to learn about? It is about the participant to tell them what are they going to get out of it, what are they going to lose from it. And this includes that compensation if there is any kind of incentive. It also tells them about whether it's going to be anonymous or confidential, or whether the data will be shared with anybody else, which is something I'll talk about in a second. It talks about their right to withdraw. We have, as part of the justice aspect of the Belmont report, that anybody at any time can decide, I don't like what's going on, I don't want to do this anymore, and that has to be completely okay. So they do have a right to withdraw. And then any contact information, so that even if in the moment they don't have problems with what happened and they're okay with you using their data, if at any point in the future they start to get uncomfortable and decide, I don't like what happened, or I need to know more about it, or I don't want you to share my data, there needs to be a way for the individual to follow up and talk to the researcher about it. Depending on the scope of the researcher, you might also provide other resources, such as mental health resources afterwards, for the individual to use. So here's an example of a participant consent form. This is one used in a study that actually I did. So here at the beginning, I talk about the purpose of the study in that first paragraph. I mentioned that the person is going to be video recorded and that they will know when they are going to be recorded. I mentioned that we're going to talk about relationship information and their individual difference and demographics. This is a 60-minute session, so they know how much time they're going to lose. I do talk about the risks and benefits to the individual, as well as the compensation clearly spelled out there, which is 1 credit. This was a research participation credit system, similar to how you have. I tell them how many participants I'm collecting so that they know kind of how big of a study is this. I tell them whether their information is going to be confidential, and I tell it it's going to be done through a code number, and how I'm going to aggregate all the information. It's not going to be shared with anybody besides me. And then they have that right to withdraw at any point. They can leave, and their video or survey data can be deleted if they want it. And then finally, that contact information they keep, so that if afterwards they decide, I actually didn't like it, I want you to delete my video, they can tell me, and I do so, no questions asked, because it's their right. It's important to keep in mind that a lot of this is about the individual's privacy, that participants always have a right to decide when, where, and to whom, and to what extent their responses will be revealed. And this could change at any time. It could be when the study, they make a decision during the study, or they make a decision a month later or a year later. It's always up to them how they want their data to be shared. Now, most researchers believe that any kind of public behavior, they've already implicitly decided that this is okay. I'm putting it out there into the world. So that is not an invasion of privacy. There's not an expected level of I'm not being observed, unless, if you're doing something where anybody can see you and you don't really paying attention to who's watching you, well, then you're okay with it. However, that is not as true when it comes to audiovisual recording. In fact, different states have different laws about how much you are recording and how much you are able to do it without telling the participant. Because while the visual cue of the person doing a behavior out in public might be something, the idea that will be recorded and very specifically logged, and the conversation that is up close and being listened to, being eavesdropped on, there is not necessarily an assumption of public revelation, public awareness when it comes to that. And there's not necessarily the belief that this will be reviewed again in the future. Yes, certainly a passerby might remember, oh, I saw some people over there hugging or arguing loudly. But if the individual doesn't really believe it's going to then go on display and be recorded. So different state laws have different rules for that to keep in mind. I also want to make sure I go over the anonymous and confidential terms again. Anonymous is when there is no connection between the participant and the data. It is full privacy. You never know that the participant gave it, which is impossible when it comes to an observational study. And then you have the confidential. This is when the researcher knows the connection between the participant and data, but never shares it with anybody else. It's that partial privacy. I've also talked a lot about this risk idea, that you're balancing the risk and the benefits. And we always want to go for a minimal risk and describe a minimal risk to the participant. This is where the risk is no greater in probability or severity than what they would experience just going about their normal daily activities. That you are just as likely to get run over a bus in the real world as you are in my study, which is theoretically very low. But you are just as likely to see something that maybe makes you a little bit uncomfortable, or do some kind of physical activity that your general lifestyle would include. That is a minimal risk. And so you need to consider this in your procedure, and it is different depending on which kind of population you are studying. And then studies that induce some kind of moderate amount of pain, stress, failure, negative emotions, those kind of things, happens a lot in psych studies where we're trying to generate some kind of emotion. This happens all the time. And so these count as more than minimal risk, but they do, just because they're kind of okay, doesn't mean they don't need some kind of justification. And that's where that cost-benefit analysis comes in. That yes, I'm introducing some risk, I'm introducing some stress and fear of failure and anxiety that are uncomfortable, that are maybe more than the minimal risk, but it's beneficial to research to this extent, and it might even be beneficial to the individual, and I need to sell why the study is that beneficial and why the risk is maybe temporary instead of long-term. And we have to do this by being very vigilant to the adverse effects and providing, as I'm going to talk about a little bit, this debriefing where we help to bring the person down, maybe let them know that the stress was intentionally induced, that it's not really representative of the individual. So there's ways that we can reduce that risk even after we have created the negative emotion. Now, I said that population might be different, so here are some examples of the physical risks that we might consider in a study. So let's say we want to do a study about walking the length of a standard hallway. Is this risky? Well, looking at this, walking the length, okay, that seems pretty good for a healthy participant. That's a minimal risk. But if you are studying a population that is elderly or recovering from some kind of physical trauma, like a knee surgery, well, suddenly this could be a lot more damaging and presents more than minimal risk. It could be falling or tearing a wound. So considering the activity, it's not just for the normal individual. And the opposite is true. Let's say I want to do a study where I understand swimming 500 meters. Well, that's going to be really challenging for most people. I know I'm a terrible swimmer. So for the general population, this might be considered more than minimal risk. But if you're getting a high school swim team, varsity, who do this all the time, and this is easy for them, that might be minimal risk. So think about your population when you are understanding risk. If there is a high anxiety population, you don't necessarily want to go into that population and just give them some anxiety-inducing manipulation. If it is a group that suffers from depressive symptoms, you don't necessarily want to go in there and talk about all the bad things that are happening in life and in the world. It might have a more than minimal risk on that individual. So we want to consider the privacy, we want to consider the risk, and we want to tell people as much as possible what they are going to do in the study so that they can make an informed decision to participate. But you might have been sitting through all this and thinking, but sometimes I don't want to tell them what I'm doing because it'll skew the data. We talked about reactivity when I was talking about observational studies. So there's sometimes when we don't want to get an informed consent. For instance, when we don't think that people are going to behave naturally, they, again, will have that reactivity where they're changing their behavior in some way when they know that they are being observed. Some people can't give informed consent. There are certain groups that are unable to do so. And sometimes it might be impractical or impossible to obtain the informed consent, such as with archival data or when you're doing some kind of deception study where people can't know before the study takes place. So you can maybe skip the informed consent. Again, we always want to if we can. We're not looking for reasons to not do the informed consent. It's that sometimes we can't do it and we just can't do it. So the times that we can skip it are when the behavior is fully public. Remember that it is considered that they don't have to have privacy when they're out there in the middle of a restaurant or on a street arguing, or somebody's identifying how many times somebody's pushing on a pull door going through entering the library. When it is fully public, we don't need to get informed consent. And when there is no more than minimal risk of harm, which I just talked about, this is again that amount that can occur in everyday life, then we can skip the informed consent. The IRB still comes into play here, though. You still have to submit to the IRB so they can agree with you that the behavior is fully public and that there is minimal risk of harm. So they give you the thumbs up and say, fine, you don't need to tell the person all about your informed consent. Now, I mentioned deception. So sometimes we don't want informed consent because we're going to lie to the individuals. Deception is when researchers withhold some details. It can even be that we give an informed consent, but we just don't necessarily say what the study's actually about, or we don't say one step of it, or they think they're going to do a study and then halfway through the study somebody runs in screaming. I think of the famous deception study where people think they're coming in just to do a group project, just to fill out a survey, and then the smoke starts coming up through the floor. Well, we couldn't tell people before that smoke was going to start coming up through the floor, and we were going to measure how quickly they reacted to the smoke coming up through the floor to see if the number of people in the room caused them to react faster. We can't tell them all of that. We need to deceive them. A lot of social psych is about understanding individuals without them realizing what they're doing and how the environment has changed. So we need to deceive. So again, some examples of this are withholding the true purpose of the study, extremely common to avoid that reactivity. If there's any kind of confederate in a study, these are actors who are playing a role. Well, we don't want the participant to know that it's an actor. We want them to think that these are normal individuals. For instance, there's the famous Solomon Asch line study where they were asked to tell which line is the tallest, and it went around the room, and all of the other participants were Confederates. They were pretending, and they all said the wrong answer to see if that one guy in the middle would look at it and say, well, I know that everybody said the wrong answer, but should I say the right answer, or should I go along with what the group? Should I conform with the group? We also have the famous Stanley Milgram study where somebody thought that they were electrocuting another individual for getting questions wrong. So they ask them a study, they answer wrong or they don't answer. Well, you push a little button and it electrocutes the person on the other side. Well, that person there in the center who was being electrocuted was actually an actor who pretended to be electrocuted instead of a real person. Now, again, the participant didn't know that. And there are still to this day some questions about that middle Milgram experiment there, about whether that would have been ethical based on our modern understandings of beneficence and justice. Also, if there's any kind of fake feedback where we want the person to respond in a certain way to how they performed, so they give a presentation and we tell them it was terrible, how do they react? And this could be even if it is a great study. We don't want to tell them that we're going to lie to them in any way. So these are situations where we're increasing the risk because maybe somebody will experience something negative from the deception. They don't know what they're getting into. So we have to be very careful that we walk through with them afterwards what they went through and what effects it could have on them. So the objections to this deception and why we try to not do deception. There's an ethical objection, obviously, that lying and deceit are in our culture immoral acts, and so we want to not do those things. There's also a pragmatic objection. This is that if people are constantly concerned that they are going to be lied to and that something's not going to be presented the way it should be, or they're going to experience something completely random, if they read too many social psych studies and think, oh yeah, there's going to be smoke coming out of the floor, or I'm not actually electrocuting somebody, but they're going to make me feel it, or everybody in the room is lying, then people are going to react in different ways. In fact, this is an issue in intro psych students. I've found that when doing studies that use intro psych students, it's really good to get your study off the ground at the beginning of the semester, get it going and done, because if you wait until the end of the semester to get participants, all of those participants have already learned through their intro psych course about all of these deception studies. And so they're kind of watching out for it and they might not trust. So the more we do deception, the less likely we're going to get authentic participation. And participants may just not come in at all, in which case we have that non-response bias. So there's other ways to get around this. Researchers might choose not to deceive. We also can't deceive them about anything that affects their willingness to participate. The kind of deception we're doing has to be such that afterwards they could say, oh yeah, well that was fine. I wouldn't have necessarily said no if I knew that you were going to do that. This is why that Milgram study is questionable, this very specific instance, because if people had known that they were going to be electrocuting someone and that person wasn't going to be real, they might have decided, I'm not interested in this. I don't really want to electrocute anybody. I don't want to do that kind of thing. That's too stressful whether or not it's a real person. That being said, with all those practical implications about research, participants might not want to participate in research. Well, we actually have heard that participants don't mind deceptive studies if it was conducted with that respect for the person and there was what's called a thorough debriefing. A debriefing is when you tell the participant about the study after it's over. So everything that happened to them, you let them know, ha, we tricked you, it was actually an actor the whole time, or the smoke wasn't real. You tell them everything so they feel they're in on it and they don't have any questions. They know exactly what happened to them. So it's kind of like putting the informed consent, the full, real informed consent at the end. And you tell them, why did you feel you needed to deceive them? And what would have happened if you hadn't deceived them? How would their data have not been good? And so that kind of has the effect of participants say, oh, well, it's cool that I was deceived and I did something I didn't expect. And that was kind of an interesting twist to this story and twist to this research. So in deceptive studies, you always want to do this debriefing. But even then, I might do a debriefing in any study that I do, just to make sure that when the person leaves, yes, they read an informed consent where they have an idea about the project, but once they've actually seen the questions I'm asking, and once they've actually done the research, they come out of it and you remind them of why it was all important and why they took this study. The debriefing is pretty much always a good tool. So the general guideline when it comes to the debriefing is always leave the participants as good, if not better, than when they arrived. And some ways you can do this is by providing extra support, again, some mental health resources. Make sure you sit down with them. The Milgram example of the electrocuting the actor, what they did, actually, there's a big book written about it, that afterwards they had the participants meet with that actor, who apparently was a jovial Irish guy, is how he's described. And he would sit there and talk to them and say, oh, look, I'm fine. I'm great. Thank you so much for participating in the study. That was so wonderful. And I want you to know that I'm okay and you're not a bad person. And then all of the participants who played in the Milgram study also had some counseling afterwards to make sure that they knew that we developed a very specific scenario to kind of force you to electrocute this individual. And we don't believe that you're the kind who electrocute an individual. We think humans would electrocute. This isn't a you thing. This is a people thing. And we're working to figure out how to undo that, and all of these positives so that the participant can leave it feeling like, okay, even though something happened that I'm not necessarily comfortable with, I'm finding ways to cope with it, or I'm finding ways to be comfortable with it, and maybe to even feel more knowledgeable or self-assured because of it. Leave the participants as good or better than when they arrived. Of course, all of these rules and regulations apply to the general population. There are certain vulnerable populations that a lot of these don't apply to, and we can't necessarily get informed consent or deceive. So children, prisoners, people with impaired decisional capacity, people at risk for suicide, as well as pregnant women, fetuses, and newborns are generally considered vulnerable populations who we can't necessarily do research on, need to be very careful about our incentive structure, need to make sure we're not adding undue stress. Children aged 12 through 17 specifically require parents to consent to it because the child might not really understand the risks that are being presented and might not be able to think through the long-term effects of participation in a study. And even if the parent consents, though, the child still has the individual ability to refuse. So the parent says, yeah, this is fine. Well, the child says, well, what I understand of it, I'm not okay with it. When it comes to prisoners, these individuals don't have a lot of autonomy in general, so they have to be protected from any kind of forceful incentive. It's also what's called the dull prison life, where even the smallest inducement, the smallest, oh, this is just irregular from normal prison life, that can lead to participation, even though the individual might rather not do the study. They're just looking for something interesting, or everything feels like a high inducement. So keeping those incentives very minimal, keeping it more similar to how their normal routine life is, so they don't feel unduly motivated to participate. We also need to make sure that for prisoners in particular, that there is no suggestion that their treatment or parole could be affected by their, and suggestion or reality that their treatment or parole could be affected by their participation. They are completely free, absolutely no consequences to participation. Not even good consequences, because then if they don't participate, that's a negative consequence. So always make sure the incentives are minimal for prisoners. The last three vulnerable populations to talk about are people with impaired decisional capacity who cannot have an understanding of the informed consent. Instead, a legal guardian must give that consent. We also have people at risk for suicide. This is generally understood that the more than minimal risk is met by simple daily behaviors. So everything introduced is a more than minimal risk. And then finally, the pregnant women, fetuses, and newborn, there may be more vulnerability to stress that could have adverse effects on the fetus or the newborn. And then there's always potential unknown risks associated with pregnancy. So any of these populations need to be treated very explicit about the benefits and the risk provided to them, and a reason for studying that population specifically. Now, most of what I've talked about for the ethics so far has been framed in an understanding of human research, but animal research also constitutes about 8% of psych research. Here, there are 3 R's to be considered. The first is replacement, which is to find any kind of alternatives to the animal testing as possible. If there's not a reason for you to be studying rats and monkeys and whatever animal for your study to use those, then don't. Find some other synthetic representation or modeling, or don't do the study. There's also refinement, which is to minimize the animal's distress. This is particularly in between studies to make sure that they have cozy cages and habitats for them to live in between the study, and during the study there's not extra stresses, that they're being handled well when they're being put into a maze and taken out of the maze, so that the only distress they're experiencing is from the specific manipulation and nothing else. Finally, there is the reduction, which is to use as few animals as possible. This is a consideration of sample size, and if we are going to do harm to any animals, make sure it is a minimum number of animals. That it's not just kind of taking all the rats and all the monkeys and causing some kind of distress. And there is a committee that is dedicated specifically to this animal research that was developed to talk about the IRB, which is the Institutional Review Board for Human Subjects and Human Research. There's also the IACUC, the Institutional Animal Care and Use Committee. So again, a board who just makes sure that you're meeting these 3 R's when it comes to animal research. So as a quick review of all that we learned today, we talked about sampling and understanding the idea that our sample does not always match our population. So we have some form of sampling error, that error of estimate, how much our sample does not represent our population. We also talked about different kinds of representative sampling, how we are trying to get our sample to look as much like the population as possible through probability and randomness, and then the unrepresentative or non-probability sampling that add in bias, but are often used by researchers. We then segued into talking about ethics and 3 principles of how we are going to get our participants and how we're going to treat our participants, particularly making sure that we are giving them informed consent and thinking very carefully about the kinds of participants we are bringing in and how we are treating individual participants differently, how we are informing them and considering their risk and benefit uniquely depending on the population they come from. And then a little bit about deception, why it can be used, how it can be used correctly, and especially how to make sure the individual leaves your study feeling better than when they arrived. So next week we are going to dive into some actual hard research stuff. We've talked about how to get samples, and we've talked about how to do surveys. Well, now we're going to talk about how to use the data through correlational research. That's it. See you next week.